Hi, this is a how-to video on how to easily find unwanted double precision usage in MATLAB code or in Simulink models. So here is the use case. You're developing an embedded system for deployment on a CPU that has floating point hardware for single precision, so it can be small and fast and lean code. But this hardware does not have double precision floating point hardware support. So any use of double precision would have to be emulated with software libraries, and that would be big and slow. For example, if you were using the ARM Cortex M4 flavor that came with a floating point unit, that unit only supports single precision, not double precision. In addition, you're using model-based design with MATLAB and/or with Simulink. You want the C code generated from your model to be lean and fast, so that means you want to eliminate any double precision usage in your model. This video will show you how to accomplish that easily. So there are automated tools that model-based design provides for finding these unwanted doubles. These are available for MATLAB code. You can use a MATLAB Coder code generation report option called Highlight Potential Data Type Issues. You can also find this in Simulink models using Model Advisor using the strict singles checks. And we'll demonstrate that. First, let's give a quick look at a cheat sheet for doing this in doubles. Key points are you need to configure. This is from the command line. You can also do it with the MATLAB Coder app. So from the command line, you configure your coder options. Anytime you're going to singles, you want to use C99 libraries because things like floor have a single precision version. So otherwise you'd have to jump up to double, which is what you don't want. And you need to turn on this highlight potential data type issues feature. So once you've done that, you call CodeGen as usual for your MATLAB file. And then you'll see a view report link. You'll want to launch that report. Once you get into that report, you'll go to this tab here that says Code Insights. In there, you'll look down and find double precision operations. And then you can click on that links, which will highlight code in your MATLAB code. And you can trace that over to see the C code as well. And if you have a keen eye, you can see that this 0.1 has no F after it, so it is a double precision, which was what you wanted to avoid. Similarly, in Simulink, you can go to the Models menu, Launch Model Advisor here, and then once you open that, go to the top and use the Find command and search for the word single. You'll find a check about identifying questionable operations for strict single designs. Once you've selected that, you'll see a pane like this. You'll click the Run checkbox, and if doubles are in the model, you'll get a bunch of links like this, and you can follow the links. So let me demonstrate both of those with a live demo. Whoop. Okay, so here we have a simple math function doing some multiplies and a relop. And we're going to generate code for this. The input is single precision, and you may think you're getting all single precision from that code. And as I showed on the cheat sheet, key thing is you have C99, and you also have this highlight potential data type issues. And then you can generate code. So I've already run that, and now I can just click this link to bring up the report. And in the report, as I showed you, you would come over here and click Code Insights. You would expand this, and then whatever links are here, you can click on them. And that has highlighted this for us. And again, we can see that that is actually double precision code. So that has found those for us. If we were to go back to that model, the original MATLAB code, it may be surprising that this is actually a double, but cogeneration was able to optimize this, knowing that 3.5 has the exact same value in single as in double, so you don't actually need to change that one. But this one cannot be perfectly represented in the single, so it stays in the doubles world. And so here you could just explicitly force this to be a single. And if we were to go back and rerun this code, generation process. Okay, now let's bring up the report. Okay, let me bring the report onto this screen. Let's look at the code insights. Under potential data type issues, it does say I have single precision operations, but in this case I do want single. The double precision operations are gone. All right, so that shows doing that with the MATLAB command line. Again, you can reach this through if you prefer a graphical user interface, you could use the MATLAB Coder app and find the corresponding parameter to this and get the same results and the same cogeneration report. Now let me bring up the Simulink model. So we have a Simulink model, which in this case I have the display data types, port data types shown. So in this case, with a quick eye, you can detect that there are some doubles in here, but sometimes those may be hidden below some subsystems or inside some other things. For example, there are also doubles inside this MATLAB function block, and I'll show how the Model Advisor can find those for you, both the obvious ones and the more subtly hidden ones. So let's go to Analysis menu, take the second choice to launch Model Advisor. I want to run this on the whole model. Some situations you may only care about cogeneration for subsystem, and in that case you would select that. But we care about the whole model here. So let's bring this up, and now right now it remembered where I was before, so it had already found this strict single check for me. But if I didn't know where that was, it could do a, say, single here, and it found 6 different things, and in this case the one we wanted is the first one. So turn that on with a checkbox, come over here and say run this check, and I've already run it before so it has the results, but we can come in here and see this list of things in the model that have double precision. So this signal is double precision and so forth. Let me make this a little smaller. And we can see it's talking about the product, the constant, and the gain. Also, if we click inside of here, it'll take us inside the MATLAB function block. And again, we see this is MATLAB code inside the MATLAB function block. We can see that this is also not double. So again, if we were to change this to single, we can save that. Let's go back to Model Advisor. Let's go back to some of the other blocks we had. So part of the problem is here we have 3.5 and we're saying inherit the same as the constant. Well, that constant is a double in MATLAB. But let's explicitly say we want that to be a single. And also let's say that we want this to be a single. Whoop. So again, it's inherit from the constant value. So we can say that's a single. Another way is, we could also come and go to this and say that it's single this way, explicitly. And since this is inheriting from that, that will become a single. So if we do update diagram, we should see singles. And those singles have propagated through here, for example, on the product block. So let's go back to Model Advisor and rerun that check and see how we're doing. So all the doubles have disappeared, and we were able to easily find it using those tools. Okay, so Again, we've shown how to easily find doubles using this highlight potential data type issues with MATLAB Coder using the command line, or you can also use the Coder app. And then with Simulink, we used Model Advisor to find all the doubles, whether it was in a block, MATLAB function block, or in stateflow. Would have also worked as well. Okay, that ends this video. Thank you.